Onto the tail linkage installation. There's a linkage lever here which has got two flange bearings in it. There's two ball links, one longer one that goes opposite the hub, and this connects down to the rudder servo, and then there's a shorter one which is going to go to the push rod down to the tail. This is mounted up between the frames and this recess here, where there's the two pre-drilled holes for the M3 bolt, and there's bushes to go between the frames, the longer one on the short ball link side, the shorter one on the longer ball link side, just to stagger the crank over towards the rudder servo. So we'll install that up now. Now once you've got the tail lever mounted off, you can then ping it up forward to go into the slot, and then you can put the ball links on, and then the lever and the ball links will rotate or will swing through the arc of this little recess cut out in the carbon frame. Something like that. Very neat system. Next up, the boom support, the boom braces support goes on. That has got a recessed slot cut in the carbon frames, which that little moulding goes in there, and then the whole thing is supported in place by an M3 bolt. Bag 22, we've got a couple of push rods to make up. Carbon fibre push rod with the titanium ends on there. Don't know if that's countersunk or not. And also the turnbuckle for the throttle servo here. So we'll make those up. And this time the mark on the throttle push rod goes towards the front. Okay, here's our push rods in situ and squared off there. No big dramas there. Just mounted the balls to get them as square as possible with the frame, outside on the throttle and inside on the actual lever down there. Only notable thing was we did get a split in one of the Kasama ball links there, screwing it on, so the sharp-eyed review will spot an MA ball link down here, the green variety of the same 3mm core. They are a little bit smaller than the Kasama balls, so they do need a bit of reaming out with a ball sizer to get it to fit nicely. But just in case you're unsure of ball links and you're in a desperate crisis, those MA greys can be made to do the job. Moving on to the tail, we've got 6 bags. We've got a push rod and some rubber boots for the interesting linear bearing we'll look at later. We've got the vertical tail fin. There's no horizontal fin with these, no need. And so there's our clamp just for the boom supports without any provision for a horizontal fin. 4 more bags, a pre-assembled tail rotor grip, the Kasama sort that we've seen before, tail slider, crank for the tail rotor, and probably the most interesting of all, the pre-assembled Kasama tail gearbox. And this is interesting because these are spiral bevel gears, helical bevel gears here, which and they're metal. They basically give good performance. It looks like there's no end float adjustment on there at all at the moment. There's no slack in that. I can't see any way of adjusting that, although I wouldn't be surprised if there was one. The only important thing is, as they found with the closed miniature aircraft metal gearbox, you've got to keep them well lubed, and if you don't keep them lubed, the gears wear out and people get unhappy after a few months. But that's why there's an inspection port in there. There's a tube of grease, comes with that, never seen that before, and then there's the sealing plug for the porthole on there, so presumably we'll pack that with grease before we get going. There's 2 metal bevel gears in there. They're different, basically, different orientation of gear cut, the TO6 and the TO5, and that's a close view of one if anybody's interested. And I brought some spares just in case of emergencies. Here's the gear out of the bag. There's no end float in the tail shaft. There's no end float in the torque drive, and there's a little bit of backlash in the gears at some positions, which is what we'd expect, so they run nice and smooth. So we'll pack up this gearbox with the grease first of all, and then stick the plug on there. So that's our grease squidged in, which smooths and also stiffens up the drive a bit. I suppose when it heats up and it gets going, it'll loosen up a bit, but that's an appreciable little bit of load on that from the grease in there. I'll probably use some spray grease in the future that I have with PTFE in it. I don't know what sort of grease customers supply. And that's our plug in there. Looking again at the tail box, in the tail case there are two set screws down in here, and I suspect you could loosen those off and adjust the end float in the gear meshing by pulling the shaft in and out. But that's all been done nicely for us, so no worries for now. Tail components out of bag 23.2 are a little bit confusing at first. Couple of levers. One is there's a CNC crank that takes the output from the tail push rod, and that is transmitted to this alloy crank here. That alloy crank basically swings off the back of the tail gearbox there, and then there's this tail plastic push rod here, which goes from a mounting on this crank to the ball link on the slider. A little bit difficult to visualize. First of all, we'll make up by putting the ball link on the carbon plates there and mounting the crank, the CNC crank, onto the carbon plates there. That goes on with a 2.5 2.5 by 6 there, and then later the M3 pivot bolt for the push rod out to the slider will go down through this M3 hole here, and the CNC crank is attached to this with this M3 by 20mm bolt down there. So we'll put that together and show you how it goes. That's our ball link mounted onto the outer hole again of the carbon plate. There's our CNC arm mounted onto the carbon plate. CNC lever then attaches with the M3 by 20 onto the mount on the back of the gearbox. Again, no shims or washers needed here because of the care that Kasama's taken with the mouldings. Basically moulding into a little sort of standoff on the CNC, so we don't need any shim washers. That can go in reasonably tight because of the standoff, and you can see that's nice and free to move. Finally, the push rod secures onto the CNC lever with the 26mm M3 bolt, and then I didn't use any Loctite on that because we've got a nylock nut to stick underneath, which I'll do in just a sec. And there you go, you can visualize what's happening now. Push rod up and down, push rod up and down in line with the shaft, and then that's transmitted via the plastic slider to the via the plastic push rod to the slider on the tail shaft. Next up, out of bag 23.2, we take our slider. This is all CNC and brass. Now that brass slider insert sleeve is not fully wound down, and it's not CNC'd, so we'll unhook that and we'll thread lock that up. And in the meantime, we'll also be fitting our ball link into the base of the slider down there, and then we'll fit our yokes, which you can see are ball raced with our M2 bolts into the threaded holes of the yoke. And then the other end of the yoke links are snap-on ball fasteners, because the Kasama tail grip has got ball joints to put onto the sides of the tail grips. No Chinese weight modification that I can see. Oh well, that's for another day, I guess. And that's our brass sleeve fully screwed into the yoke, and then the yoke links are arranged so that the bottom one has got the cup facing up, and the top one has got the cup facing down, and so we can then secure these in comme ça with the M2 bolts, which we'll do now. If you look at the yoke carefully, there's a little recess, a little standoff on the arm, and that's the side that faces towards the bearing for clearance. And as usual practice, I've squirted the Loctite down the hole and not along the thread near the bearing to stop it from getting into the races. Once your yoke links are on, we can slide on the sleeve, snick it into the ball link of the slider, like that, and there we are, that's our assembled finish. And you're probably getting tired of me saying this, but no slop, perfectly free running, just the most free arrangement of any slider that I've ever seen. It's just a very clever design. I don't know if it's been taken from something else, doubtless someone will tell me, but look, there's a very nearly axial arc of radius on that ball link there, almost straight down the shaft, to reduce very little delta there if that's important. And there's just no binding at all in that arrangement. It's really clever, and I like these always like ball linked yokes. That's again very much an MA trait, although MA have got another ball race on the end of their yoke links just down there. Look at the tail grips now. Now this is pre-assembled. There's no play in the grips at all. They run absolutely freely. There's no need to check if this is Loctited, because this is an adjustable hub where you've got a Nylock M3 lock nut basically on the end of the hub. And that means that you can A, adjust up any slack that might develop with wear, and B, you don't have to worry about Loctiting down there. All we have to do is mount the balls on their M2 bolts onto the arms of the grips. These are for our tail blades, obviously, and then there's 2 M4 dog-eared set screws to put into the hub of the tail rotor grip. And if we have a look on our tail shaft, we've got a corresponding 2 indents ready there to take the set screws. So we'll fix all that up now. And in case any of you are wondering how the heck do I ever get that nut off if I want to take the hub off, I'll never get a socket driver down there and a pair of pliers would be awkward. The answer is you don't. You just use a 7mm spanner which goes down between the blade grips, and then you can just put some suitable wrench in there, hold the blade grips, and you just take it off like that. Dead easy, but you will need a 7mm spanner if you're going to do that. And there's our funny flat-headed ball links. They're basically been recessed so that the head of the M2x6 bolt is completely recessed within the ball link down there, so it's not going to interfere when it goes into the cup. Okay, we'll have a little trial fit there, see how it goes. Need a pair of ball link pliers for these really, and snip. No worries at all. Little bit of slop from rotation there on the heads. That's the first bit of slop we've seen in this mechanism, but runs very freely. Runs very freely indeed, as you can see down there. Rather nice. And we've dog-legged an elbow. Look at that. Let's do that. Get that out. That's better. That's your full range of travel, which, crikey, looks nearly like 45 degrees each way. There's no way we're going to be using all that, and you can see there's no prospect of that dog-legging there, even butted up straight against the hub. So plenty for our gyro to play with. The vertical stabilizer is going to fit. This is a left-facing tail, by the way, again like MA. The tail's going to fit, the vertical fin's going to fit by the rear holes going into the gearbox case like that with a couple of short M3 bolts. And then we've got another clamp which is going to go over the boom, and the front 2 holes on the fin are going to go into that, but we'll only be able to fit that up when we've finally put in our locating screws through the boom into this tail clamp here.